Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let us prove the derivative for cosecant function. This is the sixth and the last trigonometric function where we are going to prove the rule for its differentiation. We are given here with a differentiation for cosecant x, which will result into a product of two other trigonometric functions. You have here negative cosecant x times cotangent x. So similar to secant x, which we have proven in the previous video, we also have here two functions. And for this, let me use here the idea that our f of x being cosecant x can be expressed as a rational function 1 over sine x. Now, even if the numerator is just 1, let me use here the rule in differentiating a quotient of functions or rational expressions so that I could actually lead into the intended output. We know that if we have a rational function or a quotient of function expressed in this manner where our denominator is not equal to 0, its first derivative follows this rule. Copy the denominator, multiply with the first derivative of the numerator minus the numerator times the derivative of your denominator all over the square of whatever your denominator is. And again, just a guide, you cannot interchange these two terms. You may interchange these coefficients but not these two terms because they are under subtraction, and subtraction doesn't have any commutative property. So with this, considering that cosecant x is 1 over sine x, we can say that the numerator being k of x is just 1. Hence, its first derivative is just 0. That's the rule in differentiating a constant. As for your denominator, m of x, which gives us sine x, the rule for differentiating a sine, we had a video for that previously, is just equal to cosine of x. We'll be using all of this as we structure this form for this proof. Okay, so here is the proof now. For f prime of x, we'll have the denominator, that's sine x, times, okay, the derivative of your numerator, which is 0 here, minus your numerator of 1 times the derivative of your denominator, positive cosine x, all over the square, of your denominator, which is sine x. Okay, now sine times 0, that's 0, minus cosine x over the square of sine x. Let me not place the square here because I would like to separate the denominator on the next step. So you will have here negative cosine x over, again, this form, the square of sine x. This can be written as 2 sine x multiplied by each other. Hence, we can structure our function here in this manner. Negative cosine x over sine x times sine x. And with that, I would like to pair this second sine x by the cosine x, leaving negative 1 for your numerator. Hence, I could separate them into two different rational expressions. Negative 1 over sine x times cosine x over sine x. And with this now, you have negative of 1 over sine x. That's actually, okay, let me write it like this, 1 over sine x times, still, I will be writing this, all of this at once, cosine x over sine x. So you have here negative 1 over sine x, or the reciprocal of sine x is cosecant x, times, this is just equal to cotangent x. So cosine x over sine x is cotangent x. And what is this? That was our intended goal earlier. Hence, we have proven already that from cosecant x, our first derivative Okay, like this. For cosecant x, it will result to negative cosecant x times cotangent x. And we will be using some of this or this in some of the few examples later on. So hopefully you were able to follow the proof for this, because this is like the second x is unique to have its derivative a product of two other trigonometric functions. Thank you very much for watching. So what are you waiting for? Subscribe now.